Ready to sail out to Horizon Deep, which is the deepest point in the Tonga Trench. So the Tonga Trench for us is a big one because it's the second deepest trench in the world. It's a subduction trench, so it's where two tectonic plates meet each other.
What if the most incredible footage in marine history came from inside a living shark? In 2024, a camera was swallowed 1,400 meters beneath the Pacific. What it recorded left scientists speechless. From glowing bacteria to parasitic symbionts, and a predator unchanged for millions of years, this isn't science fiction. It's real, and it may rewrite everything we thought we knew about life in the deep. Ready to witness what no human eye has ever seen? Hit like, subscribe, and dive with us into the abyss, because this story will change how you see the ocean forever. Into the deep, a gamble at 1,400 meters. What if the only way to study a deep-sea predator was to let it eat your camera? In early 2024, under the pitch-black waves of the South Pacific, a team of researchers prepared to drop a dead fish into one of the most dangerous and unexplored places on Earth. But this wasn't just bait, it was a carefully engineered vessel of discovery, hiding a high-resolution camera inside the hollowed-out head of a pollock. The idea was radical, the risk was enormous, and the reward? It might just rewrite what we know about life in the deep. The Tonga Trench is a scar in the Earth's crust that stretches more than 1,300 kilometers from the northern edge of New Zealand toward the islands of Tonga. At its deepest, it reaches over 10,800 meters, where no light has ever touched. And pressure is over 1,000 times what humans experience at sea level. But even at 1,400 meters, where this particular mission was set to unfold, the pressure is more than enough to crush steel. The water hovers just above freezing. The landscape is alien. Few creatures ever caught on camera from these depths have been seen in their natural state. That's what drew Professor Alan Jamieson and his team from the Minderoo UWA Deep Sea Research Center, working in collaboration with OceanX and Kelpie Geoscience. They weren't looking to drill samples or map the seafloor. They wanted something far more elusive, an unfiltered glimpse of life at depth. A moment of true, undisturbed deep ocean behavior. But there was a problem. Traditional methods weren't working. Remotely operated vehicles, ROVs, and deep-sea submersibles, equipped with blinding lights and robotic arms, have become the standard tools for oceanic research. But these machines make noise. They vibrate. They light up the dark like sirens. And the deep-sea predator, especially sharks, don't like sirens. Over decades of observation, researchers realized that whenever large, potentially apex animals were nearby, they'd vanish the moment the cameras moved. All they had were fuzzy sonar dots and grainy shadows on film. So Jamieson's team flipped the approach. Instead of chasing predators, they would become the prey. They embedded a tiny, pressure-resistant camerano larger than a cigar inside the head of a dead pollock. A fish known for its oily flesh and strong scent, which tends to attract large scavengers. The camera, custom-built with a titanium shell and infrared capability, was designed to survive the crushing depths and low temperatures of the trench. Its mission was simple: be eaten and keep recording. The drop site was chosen after weeks of planning an underwater slope near the trench wall, where past sonar scans had hinted at something large moving in the shadows. It was remote, hard to reach, harder to predict, and no one could say what might appear, or if the camera would even survive. Deployment proved as hostile as the trench itself. Over the course of 3 days, high winds battered the ship. Winch cables froze, electronics failed. The first 3 attempts to lower the camera aborted midway due to technical issues. Tensions on the deck ran high, but on the 4th try, just after midnight, in the biting cold of an open sea, the winch released the camera. Down it went, swallowed by darkness, fading beyond human reach. For hours, it drifted slowly downward, past glowing plankton and silt particles, past thermoclines and pressure barriers. When it finally settled on the seafloor at 1,400 meters, the ocean around it was quiet, still, empty. And then came the waiting. The camera caught glimpses of small scavengers, grenadiers, and sablefish cautiously circling the bait. A few approached, nibbled, and darted away. For a while, It seemed like just another failed attempt, but then, without warning, the fish vanished from frame. The surrounding creatures scattered in a blur. The camera jolted violently. Something massive was coming, and it wasn't in a hurry. There was no dramatic lunge, no thrashing, just a shadow, a silent movement across the screen. Then the image disappeared completely. No malfunction, no static. The camera had been swallowed whole. Back aboard the ship, the research team stared at their monitors, stunned. The camera was still transmitting, but it was no longer outside a creature. It was inside. At first, they thought it might be a fluke, a malfunction. But what they saw next could only be described as unprecedented. The screen glowed faint red, murky but rhythmic. Muscle walls flexed. Cartilage arches framed the view. The camera, tucked just behind the throat of the predator, was recording what no human had ever seen. And they had no idea how long it would last. The device had no propulsion, no lighting rig, no retrieval aid beyond the winch cable tethering it far above to the ship. The plan had been bold, but basic. Drop, observe, recover. They never really expected it would work like this. But it had. A deep-sea predator had taken the bait, not with a bite, but with a calculated glide, a vacuum-like pull that had drawn the fish and the camera straight down its gullet. What they didn't know yet was what kind of predator it was, or what other life might be hiding inside. But one thing was certain: this footage had just opened a door, not into the ocean, but into a living creature from the inside out. Inside the beast, what the camera revealed. It started with a blur, then darkness, then movement. The camera was no longer on the ocean floor. It was moving, slowly, steadily, as if being carried, not dragged, not jolted, but transported with rhythmic purpose. And as it began to adjust to its new surroundings, it revealed something unprecedented in the history of marine research. They were inside a living shark. The predator that had swallowed the camera was soon identified as a Pacific sleeper shark, a massive, elusive species that rarely appears on camera and has never, until now, been studied from the inside. The team aboard the research vessel had just made history, and the device, lodged in the soft tissue near the entrance of the shark's esophagus, was still transmitting. The footage showed something almost surreal. Instead of chaos, there was calm. Instead of teeth ripping and muscles thrashing, there was precision and almost ritualistic process of feeding. The shark hadn't attacked. It had consumed, with intent. As the camera slowly adjusted to the ambient red of the shark's oral cavity, the first images became clearer. The view was a tunnel of tissue and ridged cartilage, moving in pulse waves of contraction, known as peristalsis, gently pushing the camera deeper down the predator's throat. The muscles flexed with a slow, deliberate grace. No rush, no panic. This was not a frantic killing machine. This was an animal in complete control. What stunned the researchers most was the architecture of the mouth. The shark's teeth weren't jagged like those of a great white. They were narrow, inward pointing, and slightly curved like natural barbs or fence posts. These weren't meant to shred. They were meant to trap. Once something entered that mouth, it was nearly impossible to escape. This feeding strategy reflected a kind of evolutionary genius. The Pacific sleeper shark doesn't chase. It doesn't strike. It lures, waits, and draws prey inward with stealth and suction, an ambush artist of the abyss. But the real surprise came not from the shark's anatomy, but from its guests. As the camera continued transmitting, the team noticed tiny flickers in the frame movements that didn't belong to the shark. Upon closer examination, they saw parasitesmal, translucent organisms clinging to the interior folds of the shark's mouth and throat. Likely copepods or flatworms, these ghost-like creatures twitched and swayed with each muscle contraction, living within the shark's tissue as if it were their own private ecosystem. And yet, the shark seemed unbothered. There was no inflammation, no redness, no visible immune response. The parasites weren't hiding. They weren't under attack. They were thriving. Marine biologist Dr. Alina Reyes, reviewing the footage live aboard the ship, was the first to speak the word aloud: symbiosis. It was a shocking possibility. In most fish, parasites trigger irritation, infection, and immune rejection. But here, they appeared not only tolerated but integrated. Could it be that over millions of years, the sleeper shark had evolved to coexist with its internal passengers? Some theories already existed, rare cases where parasites serve as internal cleaners or microbial regulators. But to see it this clearly, in such an extreme predator, was something else entirely. Then, something even stranger happened. As the shark subtly shifted its jaw, the camera view tilted slightly, and something near the inner cheek folds glowed. It wasn't a trick of the lens. It wasn't an artifact. It was bioluminescence. A soft, bluish-green shimmer flickered across a ridge of tissue inside the shark's mouth. It lasted only seconds, but it was unmistakable. Upon further review, the team began to hypothesize that the glow came from Vibrio bacteria, a genus known to produce light in the absence of sunlight. These microbes have been documented in species like anglerfish and lanternfish, but never in a large predator like the sleeper shark, and never inside the mouth. The implications were staggering. Could the shark be using internal bioluminescence to attract prey in total darkness? A light trap hidden within its throat? That would mean the shark wasn't just a stealth hunter, it was a living lure. As the footage continued, the strange harmony between predator, parasite, and bacteria grew more evident. The parasites seemed concentrated near the glowing areas. Some researchers suggested that they might even help sustain the bacterial colonies, cleaning tissue, reducing competing microbes, or triggering chemical responses that maintain the light. It was a triangular relationship, forged not in sunlight but in eternal darkness. The shark provides shelter and structure. The parasites maintain balance within its tissues. The bacteria emit light to attract prey, feeding them all. No one could confirm the full dynamics yet. More data would be needed, more dives, more cameras. But in these 17 minutes of footage, a doorway had opened into a world few even imagined existed. And then, the light shifted again. A final, soft contraction, then stillness, then release. The camera, against all odds, was expelled from the shark's body, not violently, not in panic, but almost gently, as if the shark had decided it had no need to digest the strange intruder. It passed back out through the mouth, floated upward slowly, still intact, still transmitting. When the team recovered the camera hours later, they were speechless. Coated in mucus and faint bite marks, but otherwise functional, the device had survived an impossible journey, and it had brought back something priceless. This wasn't just a clip for a research journal. This was a window into biology never before seen. And the question now wasn't just what did we see? It was, what else is down there? Symbionts of the abyss, the shark's hidden ecosystem. When the research team first reviewed the footage inside the Pacific sleeper shark, they expected to learn about predator behavior. They didn't expect to find an entire hidden ecosystem. What began as a breakthrough in filming a large deep-sea predator from the inside quickly turned into something far more complex and possibly more important. This wasn't just a look at what the shark consumed. It was a glimpse at what lived within it. As the infrared footage was enhanced and slowed, more details emerged from the murky red interior. Along the folds of oral tissue, near the cartilage ridges and gum line, were dozens of tiny, writhing forms. They weren't passing debris or food remnants. These were living organisms, moving with intensum gliding, some burrowing slightly, others clinging tightly to soft tissue. The organisms were translucent, almost invisible, except when caught by the narrow beam of the camera's internal IR reflection. Some had appendages that twitched like flagella. Others shimmered faintly. Their movements were purposeful, coordinated, alive. Dr. Alina Reyes and her team began cataloging the shapes and behaviors. Based on morphology and known species from similar environments, they identified two likely categories. Copepods, small crustaceans that often attach themselves to gill tissues in marine fish. Flatworms, particularly monogenean types, known for latching onto internal membranes. These parasites weren't unfamiliar to science, but what was unfamiliar was their location inside the oral cavity of a large, free-swimming deep-sea predator. And more critically, the shark showed no signs of resisting them. In most fish, parasites trigger a defense: swelling, redness, cellular attacks. But in this footage, the sleeper shark's tissue appeared healthy, unreactive. It didn't fight the intruders. It simply coexisted. To the scientists, this suggested a startling hypothesis. The shark wasn't infected. It was in symbiosis. This may be one of the most extreme examples of tolerance we've ever seen, Reyes noted. This animal lives in a world of scarcity. In the deep ocean, there's no room for wasteful conflict. Everything has to work together, or not at all. Some parasites are known to have hidden advantages. In shallow water species, they've been observed to regulate bacterial growth, clean tissue surfaces, or outcompete more harmful microbes. Perhaps, over millions of years, these parasites evolved into mutualists offering microscopic services in exchange for shelter and food. But then the footage revealed something even stranger. As the camera view adjusted and rotated with the shark's subtle jaw movements, certain spots in the mouth revealed a dim blue-green glow, a halo that shimmered gently across the interior surfaces. It wasn't strong or flashy. It was almost imperceptible, but it was real. Initial thoughts pointed to camera malfunction, but frame-by-frame analysis confirmed it. This was bioluminescence. Further spectral breakdowns suggested the light came from Vibrio bacteria, the same genus responsible for the glowing organs of anglerfish and lanternfish. These microbes generate light through chemical reactions in complete darkness. In those species, the light is used to lure prey. But never before had Vibrio, any bioluminescent bacteria, been documented inside the mouth of a large predatory shark. The implication? The Pacific sleeper shark may not just be a passive ambush predator. It may be using internal bioluminescence as bait. Imagine, a fish swimming through the abyssal dark notices a soft glow ahead, just enough to trigger curiosity. It approaches. The light is faint, but familiar, perhaps like the lure of a smaller creature. It swims closer and is pulled inward by the silent, vacuum-like suction of a waiting shark. But if the bacteria are responsible for the glow, and the parasites cluster near the glow, a new idea begins to take shape. What if all three life forms, the shark, the parasites, and the bacteria, are part of a single adaptive system? The shark offers protection, nutrients, and a stable internal environment. The parasites clean tissue, reduce infection risk, and help manage microbial balance. The bacteria produce light that attracts prey, sustaining the entire system. A biological trinity, evolving not for competition, but for cooperation. This kind of relationship isn't unheard of. In coral reefs, clownfish and anemones, or cleaner fish and groupers, show mutual benefits. In human bodies, gut bacteria perform essential functions. But this inside the mouth of a deep-sea predator was unprecedented. It forced the team to ask deeper questions. Could this be a model for extreme environment ecosystems? Is this strategy unique to the sleeper shark, or shared across other deep-sea hunters? Could similar networks of cooperation exist in species we haven't even discovered yet? As the footage ended, the camera still functional, the researchers were left with more questions than answers. But one thing was clear. This wasn't a fluke. It was a window into a parallel biology, hidden in darkness, evolved under pressures and limitations almost unimaginable to life on land. And perhaps, just perhaps, it wasn't unique to Earth. The idea of biological cooperation in deep, lightless places has long fascinated astrobiologists, those who imagine life beneath the icy oceans of Europa or Enceladus. If life exists there, it would likely resemble what was captured here. Simple, slow, interconnected, thriving in silence and dark. This isn't just marine biology anymore, said Reyes. It's a blueprint for what life can look like when everything we think we know about evolution, light, energy, independence, gets stripped away. As the team began designing new experiments, new tools, and new missions to return to the trench, one truth echoed louder than ever. Sometimes, the deepest mysteries don't live around the predator. They live inside it. The living fossil, evolution, in stillness. As the footage continued to ripple through the scientific community, a different kind of revelation began to emerge, not from the glowing bacteria or the symbiotic parasites, but from the shark itself. The Pacific sleeper shark wasn't just mysterious. It was ancient. And the more closely researchers analyzed the video, the more they realized they weren't just looking at a unique predator. They were looking at a living fossil. Frame by frame, scientists broke down the anatomical structures visible in the video. The muscles, the cartilage ridges, the positioning of the throat folds, the flexible connective tissue wall revealed something uncanny. These features hadn't changed in millions of years. What the footage captured wasn't just biology. It was prehistory, preserved in the living body of a deep-sea shark. The Pacific sleeper shark Somniosus pacificus belongs to a family of sharks with lineage tracing back over 100 million years. Some of its closest genetic relatives date from the Paleogene period, shortly after the extinction of the dinosaurs. And yet, here it was, swimming quietly through modern oceans, its design virtually untouched. Why? Because it didn't need to change. In the deep sea, evolution plays by different rules. There are no seasonal swings, no dramatic weather patterns, no predatory arms race. There's only darkness, pressure, and scarcity. And in that still, silent world, a body that works doesn't need to adapt, it needs to endure. That's exactly what the sleeper shark has done. The footage revealed slow but incredibly efficient muscular contractions, jaw motions that used minimal energy while delivering maximum effect. Its mouth functioned not like a trap, but like a low-pressure vacuum chamber, drawing prey inward with stealth rather than force. More astonishing still were the similarities to fossilized remains. In cross-referencing cartilage patterns, seen in the video with museum specimens, paleobiologists found near-identical structures, particularly around the palate and jaw Regesto shark fossils, over 50 million years old. It was as if the footage was documenting a ghost from another era, still thriving in the modern ocean. But the revelations didn't stop with anatomy. The sleeper shark's metabolism turned out to be equally remarkable. Its entire body appeared designed for conservation, low-speed motion, reduced sensory output, long digestive cycles. In an environment where meals can be hundreds of kilometers apart, this shark has mastered the art of waiting. It doesn't chase. It doesn't compete. It outlasts. Estimates based on the shark's close relative, the Greenland shark, suggest that the Pacific sleeper may live 200 to 400 years. Some individuals swimming through the trench today may have been born before the American Civil War. With lifespans that stretch across centuries, these sharks become biological time capsules. Their tissue may contain environmental signatures, changes in ocean temperature, fluctuations in prey species, even traces of human pollution. In a way, their bodies are archived, sun-written journals of Earth's hidden history. And yet, despite its age, the sleeper shark remains robust. The footage showed no signs of deterioration. The tissues were firm. The muscles operated smoothly. Even with parasites present, there was no damage, no inflammation, no decay. It wasn't just surviving, it was thriving. To evolutionary biologists, this was revolutionary. For decades, popular science has celebrated fast-evolving species bacteria that mutate overnight, birds that shift migration patterns, mammals adapting to climate change. But the Pacific sleeper shark represents the opposite end of the spectrum, a creature so perfectly adapted to its niche that evolution hit pause. This is one of the cleanest examples of evolutionary conservation I've ever seen, said Dr. Mikhail Tran, an evolutionary theorist who joined the analysis effort. It's not that the shark is primitive, it's optimized. Nature made a bet millions of years ago and never had to change it. That idea of evolutionary success through stillness isn't just poetic. It's a reminder of how diverse survival strategies can be. In a world obsessed with speed and change, the Pacific sleeper shark teaches a quieter lesson. Endurance is a form of intelligence. And in the cold abyss, that intelligence takes shape not through thought, but through biology, refined by deep time. Some scientists began referring to the shark as the monk of the deep, solitary, patient, sustained. Its lifestyle mirrored ancient philosophy: take little, wait long, waste nothing. Even its reproduction strategy fits this mold. Though little is known, it's believed sleeper sharks give birth to relatively few offspring after long gestation periods. The pups are large, slow-growing, and may take decades to mature, another reason the species has remained so stable over eons. But this stability comes with risk. In the face of modern challenges, plastic pollution, noise from deep-sea mining. Ocean-warming creatures like the sleeper shark can't adapt quickly. Their strength is in constancy, not flexibility. That's why conservationists are now pushing to designate parts of the Tonga Trench as protected deep ocean sanctuaries, not just to preserve a species, but to protect the philosophy of life the shark represents. Quiet, durable, balanced. As the researchers reviewed the final moments of the camera footage before it was expelled and retrieved, they saw the final slow contractions of the throat muscles, the glimmer of bacterial light, and the calm passage of the device outward. No panic, no pain, just a system operating in perfection. A creature that had seen the rise and fall of empires and was still gliding silently through the dark. In that silence, there was wisdom. And in that wisdom, a message. Not all progress is movement. Not all change is necessary. Sometimes, the smartest thing nature can do is nothing at all. Beyond the mouth, a new era of ocean exploration. The camera that was swallowed in the black waters of the Tonga Trench was never meant to change the future of marine science. It was an experimenta shot in the dark. But what it revealed would ripple far beyond one shark's anatomy. Because this wasn't just a scientific milestone. It was the beginning of a new way of seeing. When the team retrieved the camera coated in residue, imprinted with bite marks, but fully intact, they held more than a data set. They held proof that we could document life in the most extreme, untouched environments without interfering with it. For decades, deep-sea exploration had followed a familiar formula: build bigger submersibles, use brighter lights, chase elusive creatures across the abyss. But the sleeper shark changed that paradigm. It didn't flee, it didn't fight. It led us not through aggression or technology, but through patience and mimicry. We didn't follow it. We became something it would naturally consume. And in that transformation, we gained something we'd never had before. Its perspective, this approach now referred to in research circles as biological embedding, marks a fundamental shift. Instead of observing predators from the outside, scientists are beginning to explore the possibility of embedding sensors within natural bait, or even within the bodies of cooperative marine animals, to record from within. Already, engineering labs in California, Norway, and Japan are racing to build the next generation of invisible devices. Microcameras that can survive weeks inside an animal without disrupting its function. Biosafe sensors that measure pH levels, temperature, and digestive chemistry then dissolve naturally. Acoustic relay modules that transmit data to buoys hundreds of meters above, allowing for real-time analysis. One design even proposes a device that mimics bioluminescence, blending seamlessly into the oral glow of predatory fish. Another mimics the texture and scent of decaying fish tissue, perfect for deep bait embedding. This isn't just innovation. It's ethology reimagined, studying animal behavior without forcing the animal to behave differently. And the implications go far beyond sharks. With this technology, we could study the migration of deep-diving whales from inside their feeding cycles, the digestion patterns of giant squid, the microbiomes of bioluminescent jellyfish drifting in total silence. But perhaps the most unexpected application is not in the ocean at all. Astrobiologists, those who study life beyond Earth, are paying attention. The icy moons of Jupiter and Saturn, particularly Europa and Enceladus, are believed to have subsurface oceans beneath thick ice crusts. If microbial life exists there, it likely lives in total darkness, under immense pressure, and within closed biological systems. In other words, exactly like the ecosystem inside the sleeper shark. Inspired by the fish head cam, researchers at NASA's Jet Propulsion Laboratory are now exploring robotic prey probes devices, designed not to drill or drill through ice, but to imitate simple organic matter. These probes could be deployed into alien waters and wait passively until something comes to investigate. What began as an experiment in the Pacific could one day become the blueprint for discovering extraterrestrial life. Back on Earth, the sleeper shark has become a kind of Simbola creature that defied expectations by doing what it always does: stay still, stay hidden, and survive. But in doing so, it forced humans to rethink how we observe, how we ask questions, and how we learn. The camera's footage has now been viewed by hundreds of thousands of researchers, educators, and curious minds. It's being used in university lectures, museum exhibits, and educational films. The moment the camera slipped into darkness, then lit up from within a predator's throat, has become iconic, a rare moment where technology, biology, and wonder converged. And for the scientists who were there, it changed everything. "When I saw that red pulsing tunnel on the screen," said Dr. Alina Reyes, "I realized we weren't pushing science forward by building bigger machines. We were doing it by learning how to listen, how to wait, how to stop trying to dominate nature, and just watch it work." For Reyes and her team, the sleeper shark became not just a subject of study, but a teacher. Its anatomy taught them resilience. Its stillness taught them patience. Its hidden relationships with parasites, with bacteria, with light, taught them that ecosystems don't always roar. Sometimes, they whisper. And for all the high-tech applications and media attention, the final lesson was something older, something human. Wonder. Beneath the ocean, in places no light has ever reached, something lives. Not just exists, but thrives. In balance, in silence, in cooperation, and all it took to see it was letting go of control, trusting the wild, and dropping a camera into the dark. So what's next? The team is already planning new missions baits embedded with multi-angle lenses, chemical sensors, and microbial samplers. Other trenches are being considered: the Kermadec, the Mariana, the Puerto Rico, each with its own mysteries. But no matter what they find, one truth will remain. The most extraordinary discoveries often come not when we force nature to reveal its secrets, but when we let it invite us in.